Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on cumulative frequency graphs and box plots. If you need an extra help on cumulative frequency graphs and box plots, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video numbers 149, 150, 153 and 154, there's dedicated video tutorials there on cumulative frequency graphs and box plots. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. But actually, just before we get started, I just want to mention that whenever you're dealing with cumulative frequency curves, and particularly ones that you've drawn yourself, so perhaps part A says to draw a cumulative frequency graph, and then in part B, if you're asked to work out an estimate for the median or the lower quartile, upper quartile, interquartile range, and so on, that our answers may vary slightly depending on our curves, and that's okay because as you draw that curve, obviously the curve that I draw might be slightly different than the curve that you draw, but in terms of that median, the technique will be the same, and whenever the examiner's marking it, that they have a particular range that they can go in between. So as long as you're using the right technique, you'll be fine. Okay, let's have a look at our first question, question number 1. So question number 1 says the mass of each deer kept in a zoo is recorded by staff. And then we've got this table where we've got the mass of the deer and the cumulative frequency. So the cumulative frequency is that frequency whenever it's been added up. And then if we go on down, we've been asked to draw a cumulative frequency graph for this information. So to draw this cumulative frequency graph, what we're going to do is we're going to go back up to our table and we're going to have a look at our first category here. So we've got between 0 and 20 kilograms and we've got a cumulative frequency of 2. So that means that 2 deer have got a mass of under 20 kilograms. And we're going to plot that 2 at the end of the category. So we're going to go 20 across and 2 up. Likewise, for the next one, we're going to go 40 across and 6 up and so on. And we plot them at the end of each category because we don't know what their masses are between 0 and 20, but we know that those 2 deer weigh under 20 kilograms. So we're going to plot them at the end of each category here. So we're going to plot the 6 at 40 across, 60 across, 15 up and so on. Okay, so let's plot each of these. So 20 across and 2 up. So let's plot that. So 20 across is here. In terms of 2 up, each of the little boxes is worth 1 because it's going from 0 to 10 in 10 little boxes. So we're going to go 20 across and then up 2. So that'll be there. Okay, next we've then got 40 across and 6 up. So 40 across is there and 6 up would be here. Next, 60 across and 15 up. So 60 across and 15 up would be here. Okay, next one, 80 across and 36 up. So 80 across would be here and 36 up would be there. We have got 100 across and 58 up. So 100 across and 58 up. So 100 across is here and 58 up would be there. I just want to mention here that it's quite important that you get these points in the right place. This one here, I'm looking at it, I'm thinking it doesn't look that great in terms of the position. So I'm going to just move it slightly. So it was 36 up, which was here. Obviously, this is on a computer, so it's a wee bit trickier than with view of a pencil. Okay, next 120 across and 73 up. So 120 across and 73 up would be here. And finally, we have 140 across and 80 up. So 140 across and 80 up would be there in the top right hand corner there. So we've plotted all the points. That's fantastic. Now we're going to draw a nice smooth curve through them. Okay, so I'm going to start here at 0 and then I'm going to do a nice smooth curve through those points. So I'm going to start here and I'm going to do this curve. Now it's quite hard on the computer. It might be a bit easier on paper, but I'm going to do a nice smooth curve through those points. And that's it, I've drawn a nice smooth curve through those points. So started here at 0, because obviously here, whenever I looked at it, the first category started at 0. If it started at 10, I would have started at 10 across rather than 0. But it started at 0, so I started here at 0. Now actually, just to mention here, whenever the examiner's marking it, they would actually just start looking from here to see what you did from here up to that last point. So it curves up and it goes through those points like so. And this is what the answers on the website look like. So whenever I done it with pencil, this is what the graph looked like. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at our next question, question number 2. So question number 2 says the ages of 100 teachers were recorded. So here's the ages of 100 teachers. And the table below shows this information. So we've got their ages. So there's 12 teachers that are older than 20, but less than or equal to 30 years old. 30 teachers that are greater than 30 years old, but less than or equal to 40 years old, and so on. And then we've got this table, which is the cumulative frequency table. So instead of going from 20 to 30 and from 30 to 40 and so on, it goes 20 to 30, 20 to 40, 20 to 50 and so on. So you're adding up the ages as you go through. So we know that between 20 and 30, there were 12 teachers in that each category. Between 20 and 40, well, that'll be these 12 plus these 30. So altogether, that'll be 42 teachers that have an age between 20 and 40. So that'll be 42 there. Okay, next, between 20 and 50. Okay, so we've got these 42. Now we've got these 28 to add on as well. So that'll be 70. So the 70 teachers altogether between 20 and 50. If you add those three up, you get 70. Or I just added on the 28 onto the 42 and I got 70. Next, we want between 20 and 60. So I'm just going to add on the 22. So that'll be 92. Again, you could add up these four if you wanted to, but you're repeating the things that you've done already. And then finally, we want between 20 and 70. So we're going to add on the extra 8. So that'll be 100 teachers. And that's it. So we've completed the cumulative frequency table. Now, if we go on down, we've been asked to draw a cumulative frequency graph for this information. So to draw this cumulative frequency graph, we're going to plot each of the cumulative frequencies at the end of each category. So 30 across, 12 up. 40 across, 42 up. 50 across, 70 up. 60 across, 92 up. And finally 70 across, 100 up. So let's do that. Okay, so let's go back up again. So we have got here 30 across and 12 up. So 30 across is here. And 12 up, here we've got from 0 to 20 in 10 little boxes. So each box is worth 2. So it's very important you know that scale in these questions. So we're going to go 30 across. There's 10. And then number 2 would be 12 there. So 6 little boxes would be 12. Okay, next 40 across and 42 up. So 40 across is here. And 42 up, well, there's 40. And one more box would be 42. Next, we're going to go 50 across and 70 up. So 50 across is here and 70 up will be there in the middle. Okay, next 60 across and 92 up. So 60 across would be here. So 90 is here and then one more up will be there because each one of the little boxes is worth 2. So it'll be one little box above 90. So that's 92 there. And then finally, we've got 70 across and 100 up. So 70 across and 100 up will be there. So that's fantastic. We've now plotted all those points. Now we just need to do a nice smooth curve through them. Now, in terms of our first category, it starts at 20, so I'm going to go from 20. So I'm going to go 20 across and 0 there, because I know that there was no teachers that are aged below 20. So that's why I'm going to start here, okay? In terms of the examiner, they're just looking to see what you do from this point here to the end point. You don't actually need to do a bit of a curve there, but I think it just makes sense to do that, okay? So here, I'm going to start here, and I'm going to go up to the curve like so. Okay, so that's my curve now. It was a bit wonky there. It's a bit hard on the computer. So if I go on down, this is what I've done in the mark scheme. So whenever you go into Corbettmaths and look at the mark scheme, that's the answer. And that's it. So we plotted each of the points at the end of the categories and we've done a nice smooth curve through them. And that's the cumulative frequency graph. Okay, let's look at our next question, question number 3. So question number 3 says, the cumulative frequency graph shows information about the ages of 300 people who live in a village. So we've got this cumulative frequency graph and it goes from 0 years to 100 years. And the cumulative frequency does go up to 300. So all the people in the village are aged 100 years or younger. There's no one aged over 100 in this particular village. And then if we go on down, we've been asked to find an estimate of the median age. Okay, so what I'm going to do is I'm going to show you how I would do this question, and then I'm going to explain why I would use that technique. So if you're just interested in what the answer is and how to get it, I'm going to show you now. And then if you carry on watching just after, I explain why we use that particular technique. Okay, so there's 300 people in the village. So if we want to find the median, an estimate of the median, I take that 300, the number of people, the total number of people. And if it's mentioned in the question, fantastic. If not, you can actually just go up and see what the highest cumulative frequency is here. So that's 300. And we're going to take that 300 and we're going to divide it by 2. And that's equal to 150. So we're looking for the 150th person. And because this is an estimate, that's why we're doing that. I'll explain a bit more about that in a moment. So what we're going to do is we're going to go to half the cumulative frequency, which is 150. We're going to get a ruler and a pencil, and we're going to draw a cross from that 150 until you get to the curve, which is here. And then you're going to go down. And then whatever value that is, that's going to be your estimate for the median. So as you can see here, it's the third little box after 30. Now in terms of these little boxes, let's see what each one of them is worth. So between 0 and 10, that's 5 boxes. So 10 divided by 5 is 2. So each one of those little boxes is 2. So 2, 4, 6, 8, 10. So this would be 32, 34, 36. So it's 36 years old. So our estimate for the median age would be 36 years old. And that's it. So in terms of that question, what we done was we took the total number of people that lived in the village, which was 300. We halved it, which is 150. So we just went to our vertical axis, our cumulative frequency. We went to 150 and drew a cross and down. And we just read off that age. And that's our estimate for the median. Okay, so that's how we would approach that question. Now let's just talk a little bit about why we use that approach, okay? So if you're just looking for the answer and why that's the case, you can just move on to question 4 now, but I'm just going to explain why we use that approach. Okay, so here we've got a cumulative frequency graph. So we've got this cumulative frequency graph that would have been drawn for group data. There would have been some group data, perhaps it would have went from 0 to 10 years old, from 10 to 20. And there may have been, well, if we have a look here, we've got here, this is 10, 20, so it might have been 15 people perhaps. There might have been 15 people between 0 and 10 years old, but we don't actually have their ages. It was a group frequency table. So here we've just got the cumulative frequency being plotted on this graph here, and this graph has been drawn. So we don't actually have the actual ages of the people, the real ages of the people, because if we did have all 300 ages, what we would have done is we would have written down all 300 numbers, we would have crossed them all out, and we would have got to the middle number. And the middle number would actually have been in between the 150 and 151st person. It would be the 150.5th person. And if we had the actual ages, that's the person we would have went for. However, whenever we're dealing with these cumulative frequency questions, whenever we're finding an estimate for the median, we don't use the precise position of the median for 2 reasons. One is the data would have been group data anyway, so we don't actually know what the actual values would have been. So adding on that 0.5, then going for the 150.5 wouldn't have actually made much difference. Also, because here the data set is quite large, it's 300 people, if you'd write down the ages of 300 people in a line, perhaps they live in a village, and you were to look at the 150th and the 151st, there probably wouldn't be that much difference between their ages, so it wouldn't have made that much difference. But again, we didn't actually have the actual values, so here it's going to be an estimate anyway. And also, if you've drawn this cumulative frequency by hand, they can vary a great deal as well. So in terms of finding the position of the median, just take the total cumulative frequency and half it to find the 150th value, and just go across and down, and then that will find your estimate for the median. Okay, let's look at our next question, question number 4. Okay, question number 4. So here's our box plot. This is our first box plot question. And it says the box plot represents the amount of money that customers spend in a shop one morning. So this is the amount of money that some customers spend in a shop one morning. We don't know how many customers. We've just got this box plot. So the lowest amount of money spent in this shop was, well, we've got 0 to 10. So each one of the boxes is worth 1. So the least amount of money spent by a customer was £2. And then here, this line is the lower quartile. So that's a quarter of the way through the data. So if you were to list down all the data, the first 25% of the people spent £20 or less. So that's the lower quartile, £20 there. The median, and that's what we've been asked to work out in this question, the median here is in between 30 and 40. So that's £35. That's £35. That's the median. The upper quartile will be £40. And the highest amount of money spent by a customer in this shop was £56. Okay, but this question says to write down the median amount of money spent, so that would be £35. Okay, let's look at our next question, question number 5. So question number 5 says the table shows information about the number of hours that 260 students spent revising for an exam. So here we've got the frequencies, so 20 students spent between 0 and 2 hours, 32 between 2 and 4, and so on. And then if we go on down, we've been asked to complete the cumulative frequency table. Okay, so remember cumulative frequency, we just need to add up the frequencies. So between 0 and 2 hours, that was 20, so we can just write that in straight away. Between 0 and 4, well, that's going to be 20 plus 32, that's going to be 52. So we're going to write 52 there. Between 0 and 4 hours would be 52. Then we're going to add 48, the next one, so that'll be 100. So that's going to be 100 there. Okay, next we'll then add on the 120, so that'll be 220, so that'll be there. Then we've got another 24, so adding 24 would be 244, so 244. And finally, we've got 16 more students between 10 and 12 hours, so adding on 16 would be 260. So we've completed the cumulative frequency table. Okay, and then if we have a look, I'm just going to go up 260 students. Yep, that matches what we've got there for total cumulative frequency. And then if we go on down, we've then been asked to, on the following page, draw the cumulative frequency curve for this table. So we need to draw the cumulative frequency curve to represent this information. So remember, whenever we're plotting the points for a cumulative frequency curve, we plot the cumulative frequencies at the end of each category. So we're going to go 2 across, 20 up, 4 across, 52 up, 6 across, 100 up, 8 across, 220 up, 10 across, 244 up, and 12 across, 260 up. Because we know that they're the frequencies by the end of each category. So we're going to plot each of those points, and then we're going to do a nice smooth curve through those points. And because it starts at 0, I'm going to go down to 0, 0, and then start the curve there. Okay, so that's what we're going to do. So let's go and do that. Now, before we do that, let's just make sure we know what the scale is. Okay, so let's make sure we know what the scale is. So going across horizontally is quite easy because we need to plot them at 2, 4, 6, and so on. Going up vertically between 0 and 40, there's 10 little boxes. So each one of the little boxes is worth 4. Okay. Okay, so let's have a look at our first point. I've just put this here to help us. So we're going 2 across, 20 up. So 2 across would be there, and 20 up would be there. Okay, and take your time with these. If you rush them, you might find that you put one in the wrong place. Okay, next we've got 4 across, 52 up. So 4 across is here. 52 up, well, there's 40. Each one of the little boxes is worth 4. So let's count up 44, 48, 52. So that's there, the third little box up there. Okay, next we've got 6 across, 100 up. So 6 across would be there. 100 up would be in the middle of 80 and 120. So that'd be there. Okay, next we have got 8 across, 220 up. So 8 across would be there, and 220 going up, 200, 240. So 220 would be in the middle. So that'd be there, 220. Okay, next 10 across, 244 up. So 10 across would be there, the next one. 244 was 240, so 244 would be there, just above that. And then we've got 12 across, 260 up. So 12 across would be there, and 260 would be there in the middle of 240 and 280, so 260. So we've now plotted our points. Now we just need to do a nice smooth curve through them. Because it did start at 0 here, I'm going to go to 0, 0. Remember, the examiner is just really looking to see what you do from this point onwards, but I'm going to go to the beginning of that first category. And then we just do a nice smooth curve through those points, and you just do it the best you can. Obviously, with your paper and pencil, it's a bit harder here on the computer. Actually, is it harder? I actually find it a bit easier than I actually do on paper sometimes. Actually, that bit wasn't very good. And then there. And that's it. So that's the curve. That's our cumulative frequency curve. And actually, here's one that I've drawn earlier, and it just looks a little bit better, particularly that section there. Okay, you just want to make it as smooth as you can. Okay, and don't spend too much time worrying about it. Obviously, just do the best curve that you can, and then carry on with the question. Okay. And then part C says, use your graph to find an estimate for the median number of hours spent revising. So we want to find the median. So remember those 260 altogether. So the total number of students was 260. And I said that in the question, 260. So for the median, we're going to half that. And 260 divided by 2 is equal to 130. So we're going to find the 130th value. And remember, it's an estimate anyway, so that's why we're using just the 130th. So here we've got 120. This in the middle here would be 140. So in the 130 would be here in the middle. So you're going to get your ruler and pencil, and you're going to go across from 130, which is here, which is 2.5 boxes up there in the middle of those, and you're going to get to here, and then you're going to go down and you're going to read off this value. Now obviously this will vary a lot depending on everyone's curves as you've done this question. If I was to do this one like I've just done, what would I get? So let's just make sure we've got that in the right place. I actually think it's there. Okay, so let's see if we were to do it using this curve, what would we get? So 130 across and down, I've got it to be here. So this is 7, and each one of the little boxes, well, if we've got from 0 to 2 in 10 boxes, each one's worth 0.2. There's going to be 6.2, 6.4, 6.6, and then I've got it in between 6.6 and 6.8, so I'm going to go for 6.7 there. So for me using this one, I've got my median to be 6.7 hours. Now if we have a look at the one that I've got on the website, so whenever I printed out the practice questions and done it using pencil and ruler and so on, I found that to be, well, I went from 130 across and down, and I found it to be exactly in between 6 and 7. So that would be 6.2, 6.4, 6.5 there. So I found it to be 6.5. Obviously here we've got it to be 6.7, and it will depend on your curve, and our answers may be slightly different, and that's okay. The examiner is really looking to see, have you gone from 130 and down and got a suitable value, and there'll be a range of values that they'll take, and so they'll use a bit of common sense whenever they're marking it. So as long as you've used that technique, you should be fine. Okay, and then part D. Part D says, use your graph to estimate the number of students who spent less than 3 hours revising. So less than 3 hours revising. Okay, so you're going to go to 3 hours here, and then you're going to get your ruler and pencil, and you're going to go from 3 hours up to the curve and then across. And whenever you go up to the curve and across, this value that we read off will be the number of students who spent less than 3 hours revising. So here, if we go up, we get to here, the second box below 40, and then across. So let's read off what that would be. So that's 20 in the middle. We're going up on 4, so 24, 28, 32. So I've got that to be 32. So my estimate for the number of students who spent less than 3 hours revising would be 32, just going from 3 hours up and across, and I've got the 32. So that means that my estimate for the number of students revising less than 3 hours would be 32. If I wanted to know how many students revised for more than 3 hours, I'll just take that away from 260, and that'll be how many would spend more than 3 hours revising, and that'll be my estimate for that. But in this case, it wanted less than 3 hours, so that would be 32. And I'm just going to go to the solution on the website. With the solution on the website, I went up and across, across, and I got the 32 as well. So hopefully sometimes we might match whenever we get our solutions like I did here. Okay, let's look at our next question, question number 6. So question number 6 says, as part of a dog show, each dog completes an obstacle course, and the box plot shows the distribution of times taken to complete the obstacle course. So we've got seconds here going from 0 to 50, and each one of the boxes is worth 1. So the quickest one was 9 seconds. The lower quartile is 15 seconds. The median here would be 18 seconds. The upper quartile is 25 seconds, and the highest, the longest amount of time would be 45 seconds. And part A says write down the median. So the median here is 18 seconds, because obviously each one of the little boxes is worth 1. So then starting at 20 and going 1 across, 2 across would bring us to 18 seconds. So that's 18 seconds. Okay, part B says write down the upper quartile. So the upper quartile is this line here, which is 25 seconds. So 25 seconds. Okay, part C says the range. Well, the range is the biggest take away the smallest, or in this case, the longest time take away the shortest time. The longest time is 45 seconds, and the shortest time is 9 seconds. So if we do 45 take away 9, that'll tell us the range. And 45 take away 9 is 36. So the range is equal to 36 seconds. So 36 seconds. And we got that by doing 45 take away 9. That's equal to 36. And then finally, part D says to work out the interquartile range. So this is the range, the largest take away the smallest, or the longest time take away the shortest time. The interquartile range is what you get whenever you find the spread of the middle 50% of the data. So if you do the upper quartile, subtract the lower quartile, that's equal to the interquartile range. So the interquartile range, the IQR, is equal to the upper quartile take away the lower quartile. So that's the upper quartile, which is this value, which is 25, take away the lower quartile, which is this value, which is 15. And 25 take away 15 is equal to 10. So the interquartile range, the spread of that middle 50% of the data, is 10 seconds. And that's it. So 10. 25 take away 15 is equal to 10. And that's it. Okay, let's have a look at our next question, question number 7. So question number 7 says, shown below is information about the total tips received by a waiter over his last 100 shifts at the restaurant. So at the end of each of his last 100 shifts, he adds up all his tips, and that's his total number of tips. And this table shows information about those totals. So on 8 of those nights, his tips were £20 or less. On 22 of those shifts, the total number of tips that he received was greater than £20, but less than or equal to £40, and so on. And then we're asked in part A to complete the cumulative frequency table. So between 0 and 20, well, we know that already. That's 8, so 8 occasions. Okay, now between 0 and £40, well, we'd add together the 8 that were less than £20 and the 22 that were between 20 and 40 to find that out. So we're going to do 8 plus 22. That's equal to 30. So we're just adding together these frequencies. Let's add on the next frequency. So that will be equal to 65. So the next one will be 65. Okay, next, between 0 and 80, well, we're then going to add on the 20. So it's going to be equal to 85. Then add on the 9, that's equal to 94, and then finally adding on the 6, and that's equal to 100. And that's great because there's 100 shifts to begin with. Okay, and then if we carry on, okay, so I've just put a copy of the cumulative frequency table there, just to help us. So remember, we're going to plot each of these cumulative frequencies at the end of each category. So we're going to go 20 across, 8 up, 40 across, 30 up, 60 across, 65 up, and so on. So 20 across, 8 up, so 20 across. Now in terms of 8 up, so we've got from 0 to 20 in 10 little boxes. So 20 divided by 10 is 2. So that means that each of the little boxes is worth 2. So we want to go 20 across and 8 up, so it's going to be 4 little boxes. 2, 4, 6, 8 will be there. Okay, next, 40 across, 30 up. So 40 across and 30 up. That one's quite nice. It's in the middle of 20 and 40. Okay, next, 60 across and 65 up. So 60 across is there, and 65 up, there's 60. 62, 64, 66, so 65 will be in the middle there. So there. Next, 80 across and 85 up. So 80 across and 85 up. Well, that again would be 82, 84, 86, so in the middle there, 85. Next, 100 across and 94 up. So 100 across and 94 up. There's 90, 92, 94 will be there. And then finally, 120 across and 100 up. So 120 across and 100 up will be there. So that's great. We've plotted all the points. Now we just need to do a nice smooth curve through them. And that's it. And that's the best curve I could do here on the computer. So it's quite tricky on the computer, but that's the curve that I've drawn. If you go to the website, this is the curve that you'll see there. And again, it looks quite similar. Okay. Actually, I think the one I've drawn on the computer is probably a little bit better. Okay, then if we have a look at part C. Part C says, use your graph to find an estimate for the number of shifts the total tips was less than £30. Okay, so we're going to go to £30 here. We're going to go up and across. So we'll go from £30 up and across, and that's brought me to here. Okay, so we just need to read off this value, and this value will be the number of shifts where the tips was less than £30. So remember, each one of the little boxes was worth 2, so that's 10, 12, 14, 16. So 16 shifts. So there'll be 16 shifts where the total tips was less than £30. I'm just going to write that again, £16. Now actually on the website, whenever I went to 30 up and across, I got that was equal to 19 shifts rather than 16. But again, the examiner's just looking for your technique, and then they'll have a range that they'll accept. Here I've done a bit more curve going down that way. On the website it was a bit steeper, so that's why it was 19 rather than 16. But again, it would just really depend on your graph and how you've drawn it, but they're just looking for your technique. So if you use that right technique of going from 30 up and across, you should be fine. Okay, part D. Part D says use your graph to find an estimate for the median. Okay, well, there was 100 shifts altogether. Remember, there's 100 shifts. So if we do 100 divided by 2, 100 divided by 2 is equal to 50. So we're going to go 50 across and down. And remember, it's an estimate. We don't actually know the number of tips in each of the shifts, so that's why we can just half the total frequency. So we're going to go from the 50 across and down. So get your ruler and pencil and go to the 50 here, across and down. And when I do that, I get to the second little box here after the middle. So the middle there is 50, so that's 52, 54. So that's equal to £54. So using my graph to find an estimate for the median, give me an answer of £54, just going 50 across and down. And on the website, whenever I done that, if I have a look here, I went 50 across and down, and I got that was equal to 51. I think on the website, my graph is a bit steeper than the one I've drawn on the computer here. But again, we're looking for the technique there. Okay, and then if we carry on, part E. Part E says use your graph to find an estimate for the interquartile range. So remember, the interquartile range is found by doing the upper quartile, subtract the lower quartile. So we're going to do the upper quartile, take away the lower quartile. Okay, so in terms of our estimate for the upper quartile, well, the total cumulative frequency was equal to 100. So we're going to find 3/4 of 100. And 3/4 of 100 is equal to 75. So 3/4 of 100 is equal to 75. So we're going to go 75 across and down. So there's 60, there's 70, so 70 is in the middle. 75 would be in the middle here, so 2.5 boxes up. So we're going to go 2.5 boxes up there, and we're going to go halfway between 70 and 80, and we're going to go across and down. So we're going to go across to the curve there, and then we're going to go down. Okay, and then we go down, and it's just before 70. So here, each one of the little boxes is worth 2. So 62, 64, 66, 68, 70. So it's in between 68 and 70. So that's going to be 69. So it's going to be 69 there. So our upper quartile is 69. Our estimate for the upper quartile is 69. Subtract the lower quartile. So we're going to do 1/4 of the total frequency. So 1/4 of 100. And that's equal to 25. So here's 20, here's 30. So in between 20 and 30 would be 25. So that's going to be here. And we're going to go across and down again. And so when we go from 25 across and down, we get to here. So again, we've got 30, 32, 34, 36, 38. So it's in between 36 and 38, so it's going to be 37. So 37. So we're going to do 69, take away 37. So when we do 69, our estimate for the upper quartile, subtract 37, the estimate for the lower quartile, we get that's equal to 32. So our estimate for the interquartile range is £32. And that's it. And whenever I've done this on the website, whenever I look at the solutions, I did get 69 for the upper quartile as well, which was great. The lower quartile I got, that was equal to 36 rather than being 37. So whenever I took them away, we got the interquartile range to be 33 rather than 32, because instead of being 37, it was 36. But it's pretty close. And that's it. Okay, let's look at our next question, question number 8. Okay, question number 8. Question number 8 says 50 students take part in a javelin competition, and the table below shows the distances thrown by the competitors. So here we've got the information about the distances thrown. So one competitor threw between 15 meters and 20 meters. 6 competitors threw greater than 20 meters but less than or equal to 25 meters, and so on. And then we've got this cumulative frequency table that we want to complete. So we want to complete this cumulative frequency table, and we just need to add together the frequency. So between 15 and 20 was 1. Between 15 and 25, that'll be the 1 plus 6, that's equal to 7. Plus 1 over 9 would be 16. Plus 17 would be 33. Plus 12 would be 45. Plus 3 would be 48. And plus 1 over 2 is equal to 50. So we've completed our cumulative frequency table. And then if we go down, part B says to draw the cumulative frequency graph for that information. So we want to plot these points. And remember, we plot them at the end of each category. So 20 across, 1 up. 25 across, 7 up. 30 across, 16 up, and so on. So let's do that. So we've now plotted our points. We now need to do a nice smooth curve through them. And again, the first category, if we have a look here, it started at 15. So we're going to start at 15 in terms of it being 0 there. Okay. Again, the examiner's just looking from that first point onwards, but I like to start there. Okay. There at 0. Okay. So we're going to curve upwards. And that's it. And that's the best I could do on the computer. If you have a look at the website, it looks quite similar in terms of that curve. And yeah. Okay, and then if we carry on with that question, part C says use your graph to estimate the median distance thrown. So we want to find an estimate for the median. Now there were 50 students that took part, 50 throws. So if we do 50 divided by 2, that's equal to 25. So we're going to go 25 across and down. So here we've got 50, and so 25 will be there in the middle. And we're going to go 25 across and down. So let's do that. So going 25 across and down will bring us to here. So in terms of the little boxes, between 15 and 20, that's going 5 across, and we do it in 10, so each one will be 0.5. So 30.5, 31, and so on. In the middle would be 32.5, 33, 33.5 there, 33.5. So the estimate for the median would be 33.5 meters. So 33.5 meters. And if we have a look at the solution on the website, let's just see what we had there. So I went from 25 across and down, and I got that to be exactly 32.5 rather than 33.5. But that just goes to show you that the answers can vary from graph to graph or from curve to curve because it's an estimate anyway. But in terms of the technique, going from 25 across and down is what they're looking for. Okay, and then if we carry on, a student qualifies for a regional competition if they threw over 38 meters. So if they threw over 38 meters, they qualify for this regional competition. And we've been asked to use our graph to estimate the number of students to qualify for that regional competition. Okay, so let's have a look at this. So we're looking to find the number of students that threw over 38 meters. So let's find where 38 is. So here's 35, 40, so 37.5 is in the middle. So 38 would be one box to the right there. That's 38 there. So if we go up and across from 38, so if we go up from 38 and across, we get to here. Now that value there is 41. That means that 41 students threw below 38 meters. So in terms of the ones that threw more than 38 meters would be the rest of them. So if we do 50, take away 41, that's equal to 9. So that means there was 9 more students. 41 threw below 38. So that means that the remainder, the 9, threw above 38. So that answer would be 9. So 9 students qualified for that regional competition. And that's it. And let's have a look at the website and see what solution I had there. So I went to 38, which was one little box to the right of 37.5, up and across, and I got to 41. And then I done the remainder, so that'd be 9, because 50 take away 41 is equal to 9. And that's it. Okay, let's have a look at our next question, question number 9. So question number 9 says, the cumulative frequency diagram shows the distribution of speeds for 60 cars on a road. So this shows the speeds of the 60 cars on a road. And then part A says, estimate the median speed. So the 60 cars, so you can see here, the total cumulative frequency goes up to 60. And if we do 60 divided by 2, that's equal to 30. So we're going to go 30 across and down. So we're going to get our ruler and pencil, and this will give us our estimate for the median. We're going to get our ruler and pencil. We're going to go from 30 across and down. And that brings us to 60 kilometers per hour. I was going to say miles per hour there, but make sure you read the axis and have a look and see what the units are there. So 60 kilometers per hour. So our estimate for the median speed is 60 kilometers per hour. And then part B says work out an estimate for the interquartile range. So we want to find the interquartile range. So the interquartile range is equal to the upper quartile, subtract the lower quartile. So let's find the upper quartile and the lower quartile. So there were 60 cars. So just go back up here. There were 60 cars to begin with. So if we do a quarter of 60, so 60 divided by 4, that's equal to 15. So if we go 15 across and down, that'll give us our estimate for the lower quartile. So 15 across and down. So here's 15, halfway between 10 and 20. So 15 is there. So if we go across and down, so across and down, brings us to halfway between 40 and 50. So that's going to be 45. So the lower quartile, our estimate for the lower quartile is 45 kilometers per hour. Now let's find our estimate for the upper quartile. So we found a quarter of 60 to be 15. So if we do 15 times 3, that's equal to 45. So we're going to go 45 across and down to find the upper quartile, our estimate for the upper quartile. And so we're going to go 45 across and down. So let's get our ruler and pencil. And it's going to be halfway between 40 and 50. So there, halfway between 40 and 50. And we're going to then go down And that brings us to 70 kilometers per hour. So that's our estimate for the upper quartile, 70 kilometers per hour. So we're going to 70, subtract 45, and that's equal to 25. So that's 25 kilometers per hour. That's our estimate for the interquartile range of the speeds. And that's it. And then if we carry on, we're then told the speed limit on this road is 90 kilometers per hour. And we've been asked to estimate how many cars exceeded the speed limit. So let's find where 90 kilometers per hour would be. So that's there, 90 kilometers per hour. And we're going to go up and across. So let's do that, up and across. And that brings us there. Now, each of one of the little boxes on the scale from 0 to 10 in 5 little boxes, that's 2, 4, 6, 8, 10. So each one of the little boxes is worth 2. So 50, 52, 54, 56, 58. So that means that 58 cars drove below 90 miles per hour, 90 miles per hour or less. And that means the remainder, the other 2, would be exceeding the speed limit. So that's going to be 2. If we do 60, take away the 58, that's equal to 2. So that's how many cars exceeded the speed limit. And that's it. Okay, let's look at our next question, question number 10. So question number 10 says the table gives information about the weights of 50 male rugby players. So we've got this information, we've got the lowest, lower quartile, the median, the upper quartile and the highest. And we just need to draw these weights or masses, but I suppose in everyday language we use the word weight sometimes to just describe their mass. So here we've got their weights. And then if we do have a look at this, we want to draw a box plot. So we've got the 5 key bits of information we need already. So we just need to do a scale and to do that. So let's do that. So the lowest is 60 and the highest is 100. So I'm going to start here at maybe 50 and go 50 and then 60, 70, 80, 90, 100 and 110 there. And I'm going to write here weight in kilograms. Okay, and now let's draw our 5 lines. So we've got a line here for 68. So we're going to get a ruler and pencil and we're going to go to 68 for the lowest. So 68 would be 2 little boxes before 70. To be 68, and you do a vertical line there for the lowest. Now it doesn't matter actually the length of it. I've just gone from here to here. You could do it bigger if you wanted to, but you know, I've just gone for that height there. Obviously keep them all the same. 74 would be 74 kilograms would be there. 82 kilograms would be here, and 88 kilograms would be there. And then in terms of the heaviest one, the highest weight, that's equal to 100 kilograms. So that's there. Actually, I'm just going to move that slightly to the right. I think that's before 100. So let's have a look here. We've got, let's just check them all, 68. We've then got 74. We've got 82, 88, and 100. And it's quite useful to check you've got them in the right positions before you start joining them, because it just makes it a bit easier to maybe rub them out and to fix them. Okay, so now we've done our 5 key lines. We just need to do our box. So our box here. And then join on the ends. In sort of some teachers call them whiskers, to join up the whiskers like that. They call it a box and whisker diagram instead of a box plot. So this is the box and these are the whiskers. So obviously here it's called a box plot. So this is our box plot. We've got our box that represents the middle 50% of the data, and then we've got our whiskers, which are then the lowest 25% and the highest 25%, and that's it. And then if we go on down. Okay, so then we're told the weights of 50 female rugby players are also recorded. We've got the lightest weight, the lower quartile, this is great, the median, that's great. And then we've got some more information here. It would be great if it just told us the upper quartile and the heaviest weight, then we could just draw them all. But we're going to need to actually work these out, because then we're told we've got the lightest weight is 51 kilograms, the lowest weight is 60 kilograms, the median is 61 kilograms, and then we're told the range and the interquartile range for the female rugby players is the same as the male rugby players. Okay, so let's go up and find what they are for the male rugby players to begin with. So let's go up to the male rugby players and let's find the range and the interquartile range for those. So in terms of the range for the men, we're going to do the highest, take away the smallest, and so it's going to be 100, take away 68 is equal to 32 kilograms. So the range for the female rugby players is 32 kilograms, so that would be 32 kilograms. And in terms of the interquartile range, well, the interquartile range for the male rugby players will take the lower quartile away from the upper quartile, so we're going to do 88, take away 74, and that's equal to 14 kilograms. So that means the female rugby players have got the same interquartile range as well, which is 14 kilograms. And that's going to be really useful for us. Okay, so we now have been asked to draw a box plot to show this information. So we've got the lightest. Let's find the heaviest. If the lightest one is 51 kilograms and the range is 32, if you do 51 plus 32, that's going to give us the heaviest female rugby player. And 51 plus 32 is equal to 83 kilograms. And let's just check that. 83, the heaviest, take away the lightest, which is 51, is equal to 32. So that's the heaviest. So that's the heaviest female rugby player. And then, we're just going to write that down, heaviest. And then in terms of the upper quartile, we've got the lower quartile as 60. We've got the interquartile range is 14. If you add the interquartile range onto the lower quartile, you get the upper quartile, which is 74 kilograms. So that's going to be the upper quartile. And let's just check that. The upper quartile is 74. Take away the lower quartile, 60, is equal to 14 kilograms. So that's right. Okay, so we've now got the lightest, we've got the lower quartile, the median, the upper quartile, and the heaviest. Let's just draw them. So we've been asked to draw the box plot. So let's see if we can use the same scale. The lightest one is 51 kilograms. 50, yep, that works. So let's use the same scales. It makes it a bit easier for comparing them if we need to. 50, 60, 70, 80, 90, 100, 110 kilograms. That's the weight in kilograms. Obviously, we're talking about everyday use of the word weight there, not newtons. So, and then we've got the weights in kilograms. Okay, so now let's draw the lines. So we've got a line for 51. Let's just get a ruler and pencil. 51 kilograms. Well, the scale is one little box is 1 kilogram, so 51 kilograms would be there. And then 60 kilograms for the lower quartile would be there. The median is 71 kilograms, which is there. The upper quartile is 74 kilograms, which is here. And then the heaviest one is 83 kilograms, and 83 kilograms is there. Okay, so let's just check those in the right position. I'm going to move that one slightly to the right there. So 51 kilograms for the lightest, 60 kilograms for the lower quartile, 71 kilograms for the median. The upper quartile is 74 kilograms, and the heaviest one is 83 kilograms. And then if we join them up, so we join up the box there, and then the whiskers there, so there and there. And that's it. That's the box plot for the female rugby players. Okay, let's look at our next question, question number 11. So question number 11 says, John did a survey about the amounts of money spent by 120 women while Christmas shopping, and the cumulative frequency table shows this information. So we've got this cumulative frequency table, and then if we go on down, we've been asked to, on the grid, draw a cumulative frequency diagram. Okay, so we're going to plot each of these cumulative frequencies at the end of each category. So we're going to go 50 across, 6 up, 100 across, 30 up, and so on. So let's do that. So 50 across, and in terms of 6 up, well, there's going from 0 to 20, that's got in 10 little boxes, so 20 divided by 10 is equal to 2, so it's going to be 2, 4, 6, so that's going to be 50 across, 6 up is there. 100 across and 30 up, so 100 across and 30 up would be there. Next, we've got 150 across and 80 up, so 150 across there, and then 80 up would be here. Next, we then have 200 across and 100 up. So 200 across and 100 up would be there. Okay, next we've got 250 and then 112 across. So 250 is there. And 112, well, here's 100. We're going up in 2, so 110 is there. 112 would be one more above there. And then finally, 300 across and 120 up. So 300 across, 120 up would be here. Okay, so we've plotted our points. Now let's do our curve. That's it, and that's it. We've drawn our cumulative frequency curve. Okay, and then if we go on down, then this is the one that we've done on the website, and it looks quite similar. Okay, then if we carry on, within part B, we've been asked to use the cumulative frequency diagram to estimate the median. So we want to estimate the median. So there's 120 women, so we're going to do 120 divided by 2, so that's equal to 60. So we're going to go 60 across and down. So 60 across, well 60's here, so if we go 60 across, that would bring us to here. One box after the midpoint there, and then down would be there. Okay, so here we're one box after this one here. So here that's 100, that's 150, so that's 125, so that would be 130. So that's 130 pound. So that's 130 pound. So that's the median, 130. And then if we carry on, John then surveyed men about the amount of money they spent while Christmas shopping, and their median was 160 pound. And then part C, we've been asked to compare the amount of money spent by the women with the amount of money spent by the men. So let's do that. Okay, so if we have a look at this, in terms of the women, we looked at their cumulative frequency curve, we drew that cumulative frequency curve, and we used that to find an estimate for the median amount of money that they spent, and that was equal to £130. And actually, just to mention, that was the same as the website, that was £130 as well. Whereas, with the men, we're told that their median amount of money spent at Christmas was £160. And £160 is greater than £130. So then I've written down that the men spent more on average than the women, as the men's median of £160 is greater than the women's median of £130. And that's it. Okay, let's look at our next question. Okay, let's look at our next question, question number 12. So question number 12 says, a university surveyed 60 mathematics graduates on their starting salary, and the cumulative frequency shows information about the salaries. So we've got this cumulative frequency curve. We've got going across horizontally, the salary, and we've got going up vertically, the cumulative frequency. And then if we carry on, part A says, use the graph to find an estimate for the median salary. Okay, so in terms of the question, we were told there was 60 graduates. So if we do 60 divided by 2, that's equal to 30. So we're going to go 30 across and down. So we're going to go to here where we've got 30 here on the cumulative frequency, that vertical axis, and we're going to go across and down. So let's get our ruler and pencil and show this. Now I always say to my students, get your ruler and pencil and show it on the diagram, because if you just read it off and if you were to make a mistake, then you're obviously going to get no marks. If you're using a pencil and a ruler and you draw on that method, you're probably not going to make that mistake because you're actually drawing it on, so it'll help you avoid making any mistakes. So that's equal to the median. If you go 30 across and down, that's equal to £60,000. So the median starting salary for these mathematics graduates is £60,000. And then if we carry on, part B, the 60 mathematics graduates had a minimum salary of £32,000 and a maximum salary of £96,000. And part B says, use this information and the cumulative frequency graph to draw a box plot for the 60 mathematics graduates. Okay, so we want to draw a box plot. So we've got the minimum and the maximum salary. So let's draw these on to begin with, okay? So the minimum salary is £32,000. Now in terms of the scale, we've got from 0 to £20,000 in 10 little boxes, so each box is worth £2,000. So you want 32,000, so 30,000 is in the middle, so 32,000 would be one box to the right there. In terms of the maximum salary, £96,000, that's going to be two boxes to the left of 100. So there's 100, that's 98, 96, that's £96,000 there. And then we've just worked out an estimate for the median previously. Our estimate for the median was £60,000, so let's do our £60,000. So that's our median there. And now we just need to find the lower quartile and the upper quartile. Actually, just going to move that one slightly to the right. The upper quartile and the lower quartile. So if we go back to our cumulative frequency curve, let's find an estimate of those. So the 60 graduates, so if we do 60 divided by 4, that's equal to 15. So we're going to go 15 across and down. So we're going to go 15 across and down. So we're going to get a ruler and pencil. And we're going to go 15, which is there, across and down. And that's equal to £50,000. So the lower quartile, our estimate for the lower quartile is £50,000. So we're going to use that for the lower quartile, £50,000. So get our ruler and pencil and then draw the lower quartile at £50,000. And that's in between the 40,000 and the 60,000 there. So that's £50,000 there. And then let's get the upper quartile. So in terms of the upper quartile, if the lower quartile is the 15th value, we're going to do 15 times 3, and that's equal to 45. So we're going to go 45 across and down, and that'll give us our estimate for the upper quartile. So get our ruler and pencil, and 45 is there, and we're going to go across to here and then down. So if we then go down, that's equal to £70,000. So we're going to go to £70,000 for the upper quartile. So the upper quartile was £70,000. So let's draw a line for that £70,000. So then we've got our box here with the lower quartile, the median, and the upper quartile, that 50% of the data, that middle 50% of the data. And then we've got our two whiskers going down to the lowest value and the highest value. So that represents the bottom 25% of the data and the top 25% of the data. And then if we carry on, we're told the university also surveyed 60 archaeology graduates, and the box plot shows information about their salaries. So we've got the two box plots here. We've got the maths graduates here, and we've got the archaeology graduates here. And we can actually look at them and compare them. You can see if they've got the same scale. Yep, they do. You can see here that the archaeology graduates, their box plot, and even the whiskers as well, are pushed further to the left. You can actually see that they're in less than the maths graduates. And then if you carry on, we're told to compare the distributions of the salaries of the mathematics graduates with the distribution of the salaries of the archaeology graduates. So we want to compare them, their salaries. So we want to see how do they compare. So as you can see, the first thing I'm going to do is I'm going to look at the median. The median for the maths graduates is £60,000. But if we go to the archaeology graduates, their median is £38,000. So that's much smaller. So we're going to say on average, the archaeology students earn less than the maths graduates because their median is much lower than the maths graduates. So that tells us that the maths graduates are more than the archaeology graduates because their median is higher than the archaeology graduates because it's £60,000 compared to £38,000. That's the median, so that's the middle value. You can see that the maths graduates are earning a lot more on average. Let's also compare how they're spread out. And to compare how they're spread out, I often look at the interquartile range, and that tells how the middle 50% of the data is spread out. And it's quite a good measure because rather than looking at the range where one person earning a lot of money, if you So if, for instance, you had one archaeology graduate that had a salary of £200,000, so way over here somewhere, then what you'd find is that actually their range is really big. And so it's affected by outliers, whereas the interquartile range only looks at middle 50% of the data. So let's find the interquartile range for both of them. So for the maths graduates, the upper quartile is £70,000, so £70,000. We had that already. And this was £50,000. So in terms of the interquartile range for the maths graduates, we take them away and we get the IQR, the interquartile range for them, is equal to £20,000. So that's that spread of that middle 50% of the data. Now let's have a look at the archaeology graduates and look at their interquartile range. So their lower quartile is £30,000. Their upper quartile is £50,000, and if you take them away, you get their interquartile range is equal to £20,000 as well. So that means that the middle 50% of the data is equally well spread out. If you look at the size of the boxes, that box has got the same width as this box. So that means that spread of the middle 50% of the data is equal. So that means they've got roughly the same spread, but obviously the maths students earn a lot more on average. So let's explain that. And that's it. I've just explained that the salaries have a similar spread as both distributions have an interquartile range of £20,000. So they've got a similar spread. But the maths graduates clearly earn more as their median is £60,000 compared to the £38,000 for the archaeology graduates. So in terms of this, whenever you're comparing distributions using box plots, I often look at the medians to begin with, and then I look at the interquartile ranges. The medians will let you know which distribution performs better or is higher or heavier or longer or whatever than the other one. But then also if you have a look at the interquartile ranges, that'll let you know how it's spread out. So the interquartile range is a good measure of spread, and that lets you know how those distributions are spread out. Okay, let's look at our next question, question number 13. So question number 13 says the length of time in minutes that 80 customers spent in a shop was recorded. So the amount of time they spent in the shop was recorded, and the cumulative frequency diagram shows the data below. So we've got this cumulative frequency diagram that shows that data, so how long those customers spend in the shop. And as you can see, the cumulative frequency goes up to 80, so that's all 80 customers, and the time goes from 0 to 10 minutes. So the longest amount of time that they could possibly spend in the shop here is up to 10 minutes. And then if we go on down, part A says find an estimate of the median. Okay, so we want to find an estimate of the median. So there's 80 customers, so we're going to take that 80, we're going to divide it by 2, and that's equal to 40. So we're going to go to 40 in terms of the cumulative frequency. We're going to go to 40 here, we're going to go across and down, and then we're going to read off that number, and then that'll be the median. So let's do that. So let's get our ruler and pencil and go to 40. And remember, it's important that you show this to the examiner, that you get your ruler and pencil and you draw this line on. Don't just read it off, because you may make a mistake as you're going across. You may go to the wrong part of the curve. And then if you go down from the curve, then you get to here. So we're in the middle of that box there. So let's see what the scale is. So from 0 to 2, that's 10 little boxes. So 2 divided by 10 is 0.2. So this would be 6, 6.2, 6.4. So it's in between 6.2 and 6.4. So that's going to be 6.3. So our estimate for the median time spent in the shop is 6.3 minutes. And then if we go down, part B says find an estimate for the interquartile range. So let's find the interquartile range. So to find the interquartile range is equal to the upper quartile, subtract the lower quartile. So let's find the upper quartile and the lower quartile. I'm going to start off with the lower quartile. So we're going to take our 80 and divide it by 4. We're going to find a quarter of the way through the data. So 80 divided by 4 is equal to 20. So we're going to go 20 across and down. So we're going to go 20 across and down, and that'll be the lower quartile. So let's do that. So again, get your ruler and pencil and go across from 20 and then down. And then we get to here, and that's 2 little boxes after 4. Now remember, we're going up in 0.2s here, so that'd be 4.2, 4.4. So the lower quartile is 4.4. So let's go down here. We're going to do subtract 4.4. Now we need to find the upper quartile. And if the position of the lower quartile is the 20th value, and we're going to do 20 times 3, and that's equal to 60, because it's 3/4 of the way through the data, and 3/4 of 80 is equal to 60. And then we're going to get a ruler and pencil, and we're going to go across to the curve, and then we're going to go down. And when we do that, we get to here, which is halfway in between these 2 boxes here. So here we've got 7, that'll be 7.2, 7.4, and that's in between 7.4 and 7.6. That's going to be 7.5 there. So our upper quartile, our estimate for the upper quartile is 7.5. So we're going to do 7.5 subtract 4.4, because we're going to do the upper quartile subtract the lower quartile. And 7.5 take away 4.4 is equal to 3.1. So our estimate for the interquartile range is 3.1 minutes. And that's it. Okay, let's have a look at our next question, question number 14. So question number 14, we're told that 40 students complete a puzzle and the time taken is recorded. And the quickest time was 72 seconds, and the slowest time was 117 seconds. And the cumulative frequency diagram shows information about their times taken. And then if we have a look here we've got the cumulative frequency diagram, and it starts here, the first category started at 70, and it goes up here, and we've got the cumulative frequency gone up to 40, which we were told in the question was 40 people. And part A says find an estimate for the median time taken. So there's 40 altogether, so we're going to half that to be 20, and we're going to go 20 across and down. And as you can see here, it's going to be 100, but always show with a pencil and ruler what you've done. So we're going to get our ruler, we're going to go across from 20, because that's half of 40, and then we're going to go down, and that's equal to 100 seconds. So our estimate for the median time taken to complete this puzzle is 100 seconds. So that's our estimate for the median. Okay, part B. Part B, we've been asked to find an estimate for the interquartile range. So for the median, we went across from 20. Well, for the lower quartile, we're going to half that, so that'll be 10. Or we could do a quarter of 40, which is 10. So let's find the lower quartile to begin with by going from 10 across and down. So 10 across and down brings us to here, and that's one box before the middle one there. So it's the one box before the middle one there. Okay, so let's see what the scale is. So from 50 to 60, that's an increase of 10 in 10 little boxes. So each little box is worth 1. So 91, 92, 93, 94, so that's 94. Or you could go to 95 and go back 1, that'd be 94. So our estimate for the lower quartile is 94 seconds, so 94 seconds. Okay, and then in terms of the upper quartile, well, if we take our 10 and times it by 3, that's equal to 30. So we're going to go 30 across and down. Or remember, we could do 3/4 of 40, and that's equal to 30. So if we go 30 across and down, we get to here. And again, always show that in terms of that ruler and pencil drawn across to the curve and down. And we get to one little box here after the middle, so that was 105, so that'd be 106, that's 106. So our estimate for the upper quartile is 106. And to find our estimate for the interquartile range, we'll do our upper quartile, subtract our lower quartile, and 106, take away 94, is equal to 12. So our estimate for the interquartile range is 12 seconds. And then part C, we've been asked to complete a box plot for the times taken. Now, if we go back up, obviously we've found the median, the lower quartile and the upper quartile. That's fantastic. Now here from the curve, it can be quite difficult sometimes to find the lowest and highest values. So often in the question we're told those. So we're told the quickest time was 72 seconds and the slowest time was 117 seconds. So that's going to be our lowest value, so the one that takes the least amount of time. And the one that takes the most amount of time is the 117 seconds. So we've got our lowest being 72, our lower quartile being 94, our median being 100, our upper quartile being 106, and the slowest time, the one that takes the most amount of time, being 117 seconds. So let's do that. So let's draw that. So here we've got our box plot, our grid for our box plot, and the scale's been drawn for us, so that's quite nice. So we just need to draw those values. So we had the lowest value being 72, we had the lower quartile being 94, we had the median being 100, the upper quartile being 106, and the longest time taken was 117 seconds. So there's the 5 values. So let's just get a ruler and pencil and draw those 5 vertical lines. So 72, so our scale is each one of the little boxes is worth 1, and just make sure that this scale is the same as the one above, and it is. So here, if we go from here down to there, that's the lowest value, it's 72. Then 94, well, that's going to be 95, so 94 is there, so that's 94. 100 is there. 106 is there, and 117 will be there. So we've drawn our 5 vertical lines. Now let's join the box up. So that's the middle 50% of the data. So the lower quartile to the upper quartile with the median there in the middle. And then let's draw our whiskers. And I tend to call them whiskers just out of habit because I used to call it box and whiskers rather than a box plot. So there's the 2 whiskers joining up the lowest value to the box and the box to the highest value, like so. So that's our box plot, and that's it. Okay, let's have a look at our next question, question number 15. So question number 15 says a supermarket surveys all of its 120 employees about how long it takes them to travel to work. And the table shows some information about the times taken. So the shortest amount of time it takes one of the employees to get to work is just 3 minutes. The median is 18 minutes, the upper quartile is 25 minutes, and the range is 34 minutes. So that's some of the information. And we're also told that the range is twice the interquartile range. So that means that the interquartile range would be half of the range because it says the range is twice the interquartile range. And then if we go on down, part A says, draw a box plot to represent this information. So we want to draw a box plot to represent that information. Now to draw a box plot, we need the 5 things. We need the lowest or the shortest amount of time, the lower quartile, the median, the upper quartile, and the longest amount of time. So let's go up and see which ones we've got. We've got the shortest, we've got the median, and we've got the upper quartile. So we need to find the lower quartile, and also we need to find the longest amount of time it takes to get to work as well. So we've got the shortest, the median, and the upper quartile, and we need to find the lower quartile and the longest. Okay, so let's start off with the longest, because we know the shortest amount of time it takes to get to work is 3 minutes, and we know the range is equal to 34 minutes. So remember, to get the range, we do the longest take away the shortest. If you take away the smallest from the largest, that gives you the range. So that means if we take the longest amount of time and take away 3 minutes, the shortest amount of time, we get the range, which is 34. So if we take the range, which is 34, and we add on the shortest, which is 3, 34 plus 3 is equal to 37. So that means the longest amount of time taken by an employee to get to work is 37 minutes. And let's just check that. 37 take away 3 is 34. So that's fantastic. Okay, so now we've found the longest amount of time it takes to get to work. Now let's find the lower quartile. So to find the lower quartile, we've been given the upper quartile, and we've been told some information about the interquartile range, so that'll help us. So we're told the range is twice the interquartile range. So that means that the range, this number, is double the interquartile range. So if we half 34, well, 34 divided by 2, that's equal to 17. So that means the interquartile range would be equal to 17 minutes. And remember, that's the difference between the upper quartile and the lower quartile. So when you take the upper quartile, which is 25, and you take away the lower quartile, which is what we're trying to find, you're going to get that's equal to 17 minutes. So what do you take away from 25 to get 17? Well, that'll be 8. So that'll be 8 minutes. Because if we had 25 minutes and we take away 8 minutes, we get that's equal to 17 minutes in the quartile range. So that's it. We've got the 5 values that we need. We've got the shortest, the lower quartile, the median, the upper quartile, and the longest. So now let's draw our box plot and let's have a look. It's got a scale drawn for us. We've got the time taken from 0 to 50 minutes. That's fantastic. Okay, so now let's draw these. So the shortest amount of time taken was 3 minutes. So let's do our first line at 3 minutes. So get our ruler and pencil and draw a line at 3 minutes. So each one of the little boxes is worth 1 here. So 3 minutes would be there, and we go down. So that's the shortest amount of time taken. The lower quartile is 8 minutes. So if we go to the lower quartile there, that's 8 minutes. So that's the first 2 lines drawn. The median is 18 minutes. So 18 minutes is the median, which is there, 18 minutes. The upper quartile is 25 minutes. So 25 minutes is here. And the longest amount taken was 37 minutes. So let's draw our longest amount of time taken, which is 37 minutes, which is there. And that's it. Actually, I'm just going to move that 37 just slightly to the right there, just so that it's in the right place. And so we've drawn our 5 lines. Now let's draw our box. So that's around the middle 50% of the data, which is the lower quartile, median, and upper quartile. So that middle 50% of the data. Then let's join up our lowest value to the lower quartile. So that whisker there. And then the upper quartile to the highest value there. And that's it. So that's our box plot. Okay, then if we go down to Part B says work out an estimate for the number of employees that take between 18 and 25 minutes to travel to work. So 18 and 25 minutes. Now I recognise those values because 18 minutes is the median and 25 minutes is the upper quartile. So it wants to find out an estimate for how many employees take in between these 2 times. If we have a look at our box plot, between 18 minutes is this line here, so that's 18 minutes, and that's 25 minutes. Now with a box plot, between each of the lines represents 25% of the data. So 25% of the data lies in between here, 25% of the data lies in between here, 25% of the data lies in between here, and 25% of the data lies in between here. So that'd be 25% of the employees. So if we go up here, there's 120 employees. So if we work out 25% of that, because 25% of the employees take between 18 and 25 minutes, if we work out 25% of that 120, that'll tell us how many employees would be there. That's our estimate. So let's work that out. So if we do 120 divided by 4, because that's defined 25%, you divide by 4, that's equal to 30. So that's it. That's our estimate for the number of employees that take between 18 and 25 minutes. And that's it. So the number of employees that take between 18 and 25 minutes would be 30. Okay, let's look at our next question, question number 16. So question number 16, we're told a teacher asked 75 students how long they revised for a test. And the cumulative frequency graph shows information about the amount of time they spent revising. So we've got this cumulative frequency graph. We're told the 75 students, and as you can see here, the cumulative frequency curve goes up to 75, so that's fantastic. And then in terms of the time going across horizontally, we've got from 0 to 120 minutes, so from 0 to 2 hours. And then we're told that 40% of the students spent less than X minutes revising. find an estimate of x. So 40% of the students. So let's find out what 40% of the students is, because we know there's 75 students altogether. The question said that there were 75 students there. So we want to work out 40% of 75. So let's do that. So let's work out what 40%, so let's just find 40% of 75 to begin with. Okay, now this is a calculator question. You could take the 75, divide by 100, and then times by 40, and you'll get that's equal to 30. Or you could find what 10% is, which is 7.5, and then times it by 4 and get 30, and so on. So because we're told that 40% of the students spent less than X minutes revising, we now know that's equal to 30 students, because if we work out 40% of the 75, that's equal to 30. So we could actually rewrite this if we wanted to. We could write it as 30 students spent less than X minutes revising. Find an estimate of X. Okay, so 30 students spent less than a particular time. So what we're going to do is we're going to go to our cumulative frequency on our vertical axis, and we're going to get our ruler and pencil, and we're going to go from 30, because 30 students spent less than a particular time. And if we go across and down, it'll tell us that particular time. So if we go across here, and then we go to here, we get to that second little box there after 50. So that's 50 there. And each one of the little boxes is worth 2 here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this would be 52, 54. So 54. So that means that 54 students spent less than 30 minutes revising. So the answer is 54. And that's it. So just to recap, we were told that 40% of the students, and we worked out what that would be, that's 30 students, spent less than X minutes revising. So we went to 30 students, we went across and down, and that time tells us the time that those 30 students spent less than revising. And that's it. Okay, and then if we go on down, part B says that 20% of the students spent longer than Y minutes revising, and we've been asked to find an estimate of Y. Okay, so let's find out what 20% of 75 is to begin with. So 20% of 75, well, that's going to be half of 30, because that's 40%, so that's equal to 15 students. Alternatively, you could find 10%, which is 7.5 and double it, and that's equal to 15 students as well. So I'm just going to rewrite this. So instead of reading it as 20% of the students, I'm now reading it as 15 students spent longer than Y minutes revising. Okay, so that's fantastic. We now know that 15 students spent longer than Y minutes revising. Now 15 students isn't very many here. If we go back up to the graph, this graph represents 75 students, and only 15 of them spend more than this particular time Y minutes revising. So they're the ones that revise the most, because only 15 of them revise more than this particular time. So if only 15 of them revise more than this particular time, what we're going to do is we're going to go down to 60, because 75 take away 15 is 60. So we're going to go 60 across and down. So we're going to go 60 across and down. And the reason we're doing that is because we know that these 15 students, it says that 15 students spent longer than Y minutes revising. So that's not many of them. So it must be quite a long amount of time revising. And that means that if 15 of them spent more than this time revising, that meant that the rest of them, 60, would spend less than this time revising. So what we done was we went to this graph and we said, well, if we go down 15, that's 60. And we're going to go 60 across and down. Because this particular time here, 60 students spend less than that time revising, and 15 students spend more than that time revising. So that's the particular time that we want. So whenever we read this value off, each of the little boxes is worth 2, so that's going to be 78. So that's 78 minutes. So Y would be 78 minutes. So that means that 15 students, which is 20% of them altogether, so 15 students spent longer than 78 minutes revising. And let's just go up and check that makes sense. Well, 78 minutes, so if you go to 78 minutes up and across, you get the 60. That means that 60 students spend less than 78 minutes. So that means the rest, the 15, the remaining, the 15, spend more than 78 minutes revising. And that's it. So that would be 78 minutes. Okay, let's look at our next question, question number 17. So question number 17, we're told that a teacher gave 100 boys and 100 girls a maths test, and the test was out of 45 marks, and the cumulative frequency shows how each group performed. And we've got the blue curve for the boys, and we've got the black curve there for the girls, and they're labelled. And then if we go on down, part A says find an estimate for the number of boys that scored over 40 marks. So we want to find how many boys scored over 40 marks. So we're going to go from 40 marks up to the boys curve and across. And then whatever number you get, that'll be how many boys scored less than 40 marks. And then the number of boys above that will be how many boys scored over 40 marks. So let's work that out. So let's get a ruler and pencil and go to 40, which is here. And we're going to go up to the boys curve, which is the blue one. So let's do that. And then once we get up to the curve, let's go across from the curve to that cumulative frequency axis, like so. And you can see it's actually just one box below 100 there. So each of the boxes, let's see what they're worth. So from 0 to 20, there's 10 little boxes, and 20 divided by 10 is 2. So each one of the little boxes is worth 2. So that'll be 98. So that means that 98 boys scored 40 marks or less, and that means the rest must have scored over 40 marks. So if we do 100, take away 98, that's equal to 2. So our estimate for how many boys scored more than 40 marks would be 2. So let's write that down, 2. Okay, then part B. Part B says, make 2 comparisons between the distributions of the boys' scores and the girls' scores. So we want to compare their distributions. Now, whenever I'm comparing distributions, I like to find the medians and compare those to see who done better on average. And then also I'm going to find the interquartile range for the boys and the interquartile range for the girls and compare them and see how spread out they are. And the bigger the interquartile range, the more spread out the results would be for that group. Okay, so let's find the median for each of them to begin with. So we were told there's 100 boys and 100 girls. So we're going to go to 50. So 50 would be here, 50. And we're going to go across and down and find the median for the boys and the median for the girls. So let's do that. So let's get our ruler and let's go from 50, which is here, across to both lines. So there and there. And then we're going to go down from both of them. So let's do that. Okay, so we've gone across and down. And so for the boys, their median would be, now each one of these little boxes is worth 1. So that'll be 24. So the median for the boys would be 24. And for the girls, that's 31, that's 32. So that's 31.5. So 31.5. So we've got the median score for both of them. And as you can see here, the median for the girls is much higher than the median for the boys. They've got an average score of 31.5 out of 45, whereas the boys have only got an average or median of 24 marks out of 45. So the girls have outperformed the boys here. So let's write that down for our first comparison. Okay, so I've just written down the girls scored more than the boys on average, as their median is 31.5 compared to 24 for the boys. So the girls perform better than the boys. Now let's look at the interquartile ranges. Now to find the interquartile ranges, well, there's 100 boys and 100 girls. So we're going to want to find the lower quartiles for each of them by going 25 across and down, because a quarter of 100 is 25. Then we're going to find the upper quartiles by going to 75 across and down and finding the upper quartiles. And then we'll take them away to find those interquartile ranges. And then once we find the interquartile ranges, we can then compare them and see which group has more spread out data. So let's do that. So let's start off with the lower quartiles. So 25. So we're going up in twos here. So 22, 24, 25. So it's halfway between 20 and 30 there. So let's get our ruler and go from 25, which is here, across and down. So across would be there and there, and then down. So the boys' lower quartile will be 13, and the girls' lower quartile will be 22.5. Okay, so for the boys, IQR, we're going to do the upper quartile, take away 13. For the interquartile range for the girls, we're going to do their upper quartile, take away 22.5. So something, take away 22.5. Okay, now let's find the upper quartiles by going to 75. So 75 will be halfway between 70 and 80. So here's 70, here's 80. So 75 will be in the middle there. So that's there. Across to here. And then we'll go down. Okay, so I've gone down from both of them. For the boys, that's the first one. We've got that to be 32.5. So that there is, if we just put an arrow there, that is there, 32.5, because you've got 30, 31, 32.5. So it's 32.5. So for the boys' interquartile range, we'll do 32.5, take away 13, their lower quartile. For the girls, their upper quartile is, there's 35, 36, 36.5. So 36.5. So that's 36.5 there, 36.5. And we'll take them away and find the interquartile range for both of them. So in terms of the girls, 36.5, take away 22.5 is 14. That's equal to 14. So that means the girls' interquartile range, the spread of that middle 50% of the data, is 14 marks. In terms of the boys, we're going to do 32.5, take away 13, and that's equal to 19.5. So as you can see here, the boys' interquartile range is 19.5. So that's the difference between their middle 50% of the data. It's 19.5 marks, whereas the girls is only 14 marks. So that means the girls' marks are closer together. They're more consistent, so they're less spread out. Whereas the boys, there's more variation. There's a bigger interquartile range, which means they're more spread out. So let's explain that. And that's it. So we're asked to make 2 comparisons of the distributions of the boys' scores and the girls' scores. Well, the girls scored more than the boys on average, as their median was 31.5 compared to 24 for the boys. So the girls scored more on average than the boys, so they've done better. In terms of the boys' results, they're more spread out as their interquartile range of 19.5 is greater than the girls' interquartile range of 14. So the boys' results are more spread out than the girls'. And that's it. Okay, let's look at our next question, question number 18. So question number 18 says, a group of primary school students run an obstacle course and the table shows some information about their times. So we've got this cumulative frequency table about their times. So we've got 4 students took between 0 and 40 seconds, 11 took between 0 and 60 seconds, and so on. And then if we go on down, we've been asked to draw a cumulative frequency graph for that information. Now what's great here is that we've got the cumulative frequencies already, so we just need to plot each of them at the end of the categories. So we're going to go 40 across 4 up, 60 across 11 up, and so on. So I'm just going to plot all of those now. Okay, so I've plotted all of the points. One thing I wanted to mention here is that the scale's going from 0 to 5, so if we divide that by 10, we get that's equal to 0.5. So when we wanted to plot 40 across from 4 up, I went to 5 and went 2 squares down because 2 squares is 1, so that's going to be equal to 40 across from 4 up, and so on. Another thing that I want to mention here is that whenever I was plotting these, that the endpoints went 40, 60, 70, 80, 100. So rather than some of the other ones where there's equal spacing, here they've got some of them that are a bit closer together, and that's just the way that the cumulative frequency table was given to us. Okay, so now we're going to draw a curve. So we plotted the points, now let's draw the curve. Now one thing to mention here is that the first category went from 0 to 40, so I'm going to start at 0, so I'm going to go down here to 0 here. Again, the examiner is going to be just looking for this point to the end, but I'm just going to start from here because that's the beginning. I know that no students took less than 0 seconds to complete this, the obstacle course. Okay, so let's draw a curve. And that's it, so that's my curve. Okay, so that's part A. And then if we have a look at part B says a group of secondary school students did the same obstacle course and their median time was 72 seconds and their interquartile range was 34 seconds. And we've been asked to compare the times taken by the two groups of students, so the primary school students and the secondary school students. Okay, now we've been told the median. Now whenever I'm comparing these distributions using the cumulative frequency curves, I like to find the medians and the interquartile ranges. So that's fantastic that we've already been given the median time for the secondary school students and also the interquartile range for the secondary school students. So I'm going to find the median time taken for the primary school students and I'm going to find the interquartile range of the times for the primary school students. Okay, so let's have a look at this. So for the primary school students, there were 30 students altogether. We know there's 30 because the highest cumulative frequency was 30, it went up to 30. So if I want to find the median, I'm going to do 30 divided by 2 and that's equal to 15. So I'm going to go 15 across and down. So if we go 15 across and down, whatever we get will be our estimate for the median time for the primary school students. And whenever I go from 15 across and down, I get to this box here. Now, there's 10 little boxes from 0 to 20, so each one's worth 2, so it's going to be 68. So our estimate for the median time for the primary school students is 68 seconds. So I'm just going to write that down here. So our median for the primary school students, so for the primary students, the median is equal to 68 seconds. And actually, just before I move on, I just want to check and see what I got whenever I done this on the website. I got a median here of 68 as well, so that's fantastic. Okay, and then let's find the interquartile range. So for the interquartile range, well, if the median was 15, we're going to half that, and that's going to be 7.5. So we're going to go 7.5 across and down. And here's 5, and there's 10, so 7.5 is in the middle there. So for our estimate of the lower quartile, we're going to go from 7.5 across and down. So let's do that. So whenever I went from 7.5 across and down, I've got to one little box after 50, so it's going to be 52. So for the interquartile range, we're going to do something to take away 52. Let's find out what that something is. So if the lower quartile is the 7.5 value, we're going to times it by 3, and that's equal to 22.5. So 22.5 would be here, so that's 22.5. So we're going to go across and down and get that value. Okay, so whenever I went from 22.5 across and down, I've got to here, and that's in between 80 and 82, so that's 81. So that means to find the interquartile range, we're going to do 81, take away 52, and that's equal to 29. So that means our estimate for the interquartile range is 29 for the primary school students. Let's have a look and see what I got whenever I done this on the website. I got a lower quartile of 52, an upper quartile of 81, and 81 take away 52 is also equal to 29. So I actually got the same answers. That's amazing. If you've done the same as well, that's amazing. Okay, so let's compare them in terms of the times to begin with. So it's an obstacle course. So in terms of whoever does better here, it'll be whoever does it in the quicker time. So the median for the primary school students was 68 seconds. And it took the secondary school students a bit longer. It took them 72 seconds on average. So the primary school students performed better on this obstacle course than the secondary school students, maybe because they're shorter. So let's explain that to begin with. Okay, so I've just explained that the primary school students were quicker with a median of 68 seconds compared to 72 seconds. Okay, now let's have a look at how they're spread out. So we're going to look at the interquartile ranges, and whoever's got a smaller interquartile range means that their data is less spread out. So that means that they're more consistent. So for the primary school students, their interquartile range is only 29 seconds, but the secondary school students, they have a bigger interquartile range. That means their results are more spread out. So let's explain that. Okay, so I've just written down the primary school students' times were less spread out, they were more consistent than the secondary school students, as their interquartile range was 29 seconds compared to 34 seconds for the secondary school students. So that means that their results were less spread out, and that's it. Okay, let's have a look at our next question, question number 19. So question number 19 says, the cumulative frequency diagram below shows the distribution of marks in an art exam. So there's been an art exam, so we've got this cumulative frequency diagram, and then if we go on down, we're told the lowest mark is 8 and the highest mark is 56, and we've been asked to draw a box plot for this data. Okay, so whenever we want to draw a box plot, we want to find the lowest and highest, which we've been given, but also the lower quartile, so we want to find the lower quartile, the median, and we want to find the upper quartile. And once we find those three things, along with the two things we've been given, we'll be able to draw the box plot. So let's find these. So here's the cumulative frequency diagram. So we want to find the median, the lower quartile, and the upper quartile. So if we look at the cumulative frequency, it goes up to 40. So you can see here the curve goes up to 40. So that means that there's 40 students altogether. So if we want to find the median, we're going to go to 20 across and down. So let's do that. So let's get our ruler and pencil and see what we get for the median. So whenever we do that, let's see what we get. Going from 20 across and down brings us to 25. So the median mark would be 25 marks. That's 25 marks. Okay, so now let's find the lower quartile. So to find the lower quartile, we're going to go from 10 across and down, because obviously if there's 40 people altogether, to find our estimate for the lower quartile, we're going to divide that by 4 to get 10, and then we're going to go across and down. So let's do that. So we go across, and then we go down, and that brings us to here. And let's look at the scale and see what number that is. So that's 10 and that's 20. So each of these little boxes is worth 1. So 15, 16, 17, 18. So that's 18. So that means the lower quartile is 18 marks, our estimate for the lower quartile. And then in terms of the upper quartile, well, we're going to then go from 30 across and down, because 3/4 of 40 is 30. So our estimate for the upper quartile will be found by going from 30 across to the curve and down. And when we do that, we get to here, which is 32. So that means the upper quartile is 32 marks. So that's fantastic. We've now got the lowest mark, the lower quartile, the median, the upper quartile, and the highest mark. So let's draw those on the diagram. And in terms of this box plot, we've got the scale drawn for us. That's fantastic. And it goes from 0 to 60. And our lowest mark is 8. And the highest mark is 56. That's perfect. Okay, so let's draw those 5 vertical lines. So let's get our ruler and pencil. So the first line is going to be at 8. So each of these little boxes is worth 1. So we're going to go 2 before 10, which would be here. And we're going to go down. So that's the first line there at 8. Then the lower quartile is 18, so it's going to be 2 boxes before 20. So there's 18. The median is 25, so we're going to go and draw a line at 25. The upper quartile is 32, so we're going to draw a line for 32. And then finally, the highest mark is 56, and so we'll draw a line there at 56. So we've drawn those 5 vertical lines. Then let's do our box in the middle, so that's the middle 50% of the data. And then join up the lowest value and the highest value to the box, like so. And that's it, that's our box plot. And then if we go on down, part B says what percentage of students scored more than the upper quartile mark. So the upper quartile was 32, so it wants to know what percentage of students got over 32 marks. Now here, with our box plot, between each of those vertical lines is 25%. So 25% of the data will lie between the lowest value and the lower quartile. 25% of the data will lie between the lower quartile and the median. 25% of the data will lie between the median and the upper quartile, and 25% of the data will lie between the upper quartile and the highest value. So we've been asked to find out what percentage of students scored more than the upper quartile. So that's going to be 25%, and that's it. Okay, let's look at our next question. Okay, let's look at our next question, question number 20. So question number 20 says, Mrs. Davis sets her class a quiz where the maximum score is 50 marks, and the distribution of scores are shown in the box plot below. So we've got this box plot going from 0 to 50 marks because it's got a maximum score of 50, and we've got the lowest value here, so the lowest score is 10 marks. The lower quartile is 19, the median is 30 marks, the upper quartile is 35 marks, and the highest score is 48 marks. And part A says write down the median score. So the median will be here, so that's going to be 30 marks. Okay, and then part B says write down the highest score. Well, this is the highest score, so that's going to be 48 because each of the little boxes is worth 1. So 45 is in the middle, 46, 47, 48, so 48. And then part C says find the interquartile range. So the interquartile range is what we get whenever we do the upper quartile, subtract the lower quartile. So the upper quartile is here at 35. The lower quartile is here at 19. So if we do 35 take away 19, that'll tell us the interquartile range, how far apart those two lines are, the lower quartile and the upper quartile. So 35 take away 19 is equal to 16. So the interquartile range is 16. And then if we go on down, we're then told that Martin scored 35 marks, and we've been asked to estimate the percentage of the class that scored lower than Martin. So he scored 35 marks. So let's go up and have a look at our box plot. So he scored 35 marks, which is here, which is the upper quartile. Now remember that 25% of the data lies between each of the pairs of vertical lines. So between the lowest value and the lower quartile, 25% of the data lies in here. Between the lower quartile and the median, 25% of the data lies in here. Between the median and the upper quartile, 25% of the data lies in there. And between the upper quartile and the highest value, 25% of the data lies in there. Now, Martin scored 35 marks. So if we go down, we're asked to find what percentage of the class scored lower than Martin. So lower than Martin will be here, this 75%. If we do 25 plus 25 plus 25, that's 75%. So 75% of the class would have scored lower than Martin. And then if we go on down, okay, and then we're told the interquartile range is a better measure of spread of a distribution than the range. Explain why. Now, we talked about that earlier. So let's go back up and have a look at our box plot. So here's our box plot, and we want to explain in this question why the interquartile range, so how the middle 50% of the data is spread out, is a better measure of spread than the range, which is the distance between the biggest value and the lowest value. So whenever we take away the smallest one from the largest one, so that distance there. So why is interquartile range a better measure of spread than the range? Well, that's because the range is affected by outliers. If a student got 0, that's going to affect the range. Even if no one else got below 10 marks, if one student gets 0, that affects the range. So those outliers have a big impact in terms of the range. Whereas the interquartile range is the spread of the middle 50% of the data, so it won't be affected in the same way as the range would be. And that's it. So let's explain that. And that's it. So just explain that one outlier will affect the range, but not the interquartile range. So if you've got one value in the data set that's an outlier that's way bigger than all the rest of them, that's going to affect the range, but it wouldn't affect the interquartile range, because the interquartile range is looking at how the middle 50% of the data is spread. So it's a better measure of spread than the range. Okay, let's look at our next question. So question number 21 says the table shows information about the heights in centimetres of 40 sunflowers in a garden. So there's 40 sunflowers in a garden, and this frequency table tells you information about their heights. So 3 of the sunflowers are bigger than 0 centimetres but less than or equal to 40 centimetres tall. 4 of the sunflowers are taller than 40 centimetres but less than or equal to 80 centimetres, and so on. And then part A says complete the cumulative frequency table. So we've got this cumulative frequency table. Okay, so we just need to add together the frequency. So between 0 and 40, we're already told that was 3. Between 0 and 80, well, that's going to be the 3 between 0 and 40 and the 4 between 40 and 80. So that's going to be 7 altogether, or you could just add on the 4. Now let's add on 6. That's going to be 13. Add on 15, so it's going to be 28. Add on 8, that's going to be 36, and finally adding on the 4 gives us 40. So that's fantastic. We've filled out the cumulative frequency table. Okay, then if we carry on, part B says draw the cumulative frequency graph for this information. So we need to plot these at the end of the category. So we're going to go 40 across, 3 up, 80 across, 7 up, 120 across, 13 up, 160 across, 28 up, 200 across and 36 up, and 240 across and 40 up. And I'm going to plot all of those now. Okay, so I've plotted all the points. So I've plotted each of the cumulative frequencies at the end of each category. So 40 across, 3 up, and so on. And the scale is quite nice because obviously going up vertically here, we've got that each little box is worth 1. So that was quite nice. And going across horizontally, they were plotted at 40, 80, and so on. So we've plotted those points. Now let's draw a nice smooth curve through them. And that's it. And that's the best that I can do here on the computer. It's actually quite tricky to do these on the computer. It's actually quite tricky to do them on paper too. Okay, but that's our cumulative frequency curve. And then if we go on down, we've been asked to use the graph to estimate the percentage of sunflowers with a height more than 110 centimetres. So we want to estimate the percentage of sunflowers with a height more than 110 centimetres. So to start off with, I'm going to estimate how many sunflowers have a height more than 110 centimetres. So let's go to this graph and let's find where 110 would be on the horizontal axis. So here's 80, there's 120, and each little box here is worth 4. So then in the middle here would be 100, that's halfway between 80 and 120. And 110 would be halfway between 100 and 120, so that's 110 there. So let's get our ruler and pencil and draw a line up from 110 and across. And I've got that equal to 11. So that could be, depending on your curve, you may have got 10, 11, 12, but I've got 11 here, as long as you've gone from 110 up and across. So we've got an estimate for the number of sunflowers with a height less than 110 centimetres to be 11. That means the rest will have a height greater than 110 centimeters, and there's 40 altogether. So if we do 40 subtract 11, that's equal to 29. So that means that 29 sunflowers will have a height greater than 110 centimeters, and the rest 11 will be less than 110 centimeters. So our estimate for the number of sunflowers with a height greater than 110 centimeters would be 29. So that's 29. Now the question said estimate the percentage of sunflowers with a height more than 110 centimeters. So that's 29 out of the 40 of them. So that's 29/40ths of the sunflowers have a height greater than 110 centimeters. So let's change this fraction to a percentage. So it's a calculator question, just going to go up. Just going back, yeah, it's a calculator question, so that's great. So we can, on our calculator, do 29 divided by 40 and get it as a decimal. And that's equal to 0.725. And that's a decimal. Let's times it by 100 to get it as a percentage. So that'll be 72.5%. So our estimate for the percentage of sunflowers with a height more than 110 centimeters would be 72.5%. And that's it. So let's write that down, 72.5. And just checking on the website, I got 11 as well for the number of sunflowers with a height less than 110 centimeters. We would then take that away from 40 and get 29, and then we get the same percentage as 72.5%. If whenever you done this on the website, you went up and across and you got to 10, that would have meant that 30 sunflowers would have a height greater than 110 centimeters. And then as a percentage, that would be 75%. If you got 12 whenever you went up and across, you would have got 28 having a height greater than 110 centimeters, and that as a percentage would be 70%. But I've got here 72.5% because I got 11, and then that meant that 29 had a height greater than 110 centimeters. And that's it. Okay, let's have a look at our next question, question number 22. So question number 22 says, a shop records how much profit they make each day. And the cumulative frequency graph shows information about the profit made over the past 200 days. So this cumulative frequency diagram represents how much profit the shop makes in each of the last 200 days. And we've got from 0 to £1,400. So the most amount of profit that they could have made in one of the days would be up to £1,400. And then we're told that one of the 200 days is chosen at random. So one of these days is chosen at random. And we've been asked to use the graph to find an estimate for the probability that the day chosen at random, the profit on that day was between £700 and £1,100. So let's find out how many days the profit was less than £700. Let's find out how many days the profit was less than £1,100. And the difference between them will be how many days, our estimate for how many days the profit is in between £700 and £1,100. So let's start off with £700 to begin with. So we're going to get a ruler and pencil, and we're going to go to £700 on the horizontal axis here at profit. We're going to go £700, which is there, up and across, and we get to there. So one box below the midpoint. Okay, so in terms of these boxes, let's see what they're worth. So from 0 to 50 in 10 boxes, so each box is worth 5, so it's 50, 55, 60, 65, 70. So we've gone from £700 up and across, and what that tells us is that our estimate for the number of days where the profit is less than £700 would be 70. So we're estimating that 70 days the profit was less than £700. Now let's repeat that for £1,100, and that'll tell us our estimate for how many days the profit is less than 1,100. And then if we take them away, that'll tell us our estimate for how many days we expect the profit to be between £700 and £1,100. So let's do that. So let's get a ruler and pencil and go to £1,100, which is there, and up and across. And in terms of that, it's the one box above 175. In the middle will be 175, so that'd be 180. So that's 180. So that means that our estimate for the number of days where the profit is less than £1,100 would be 180. So most of the days the profit is less than £1,100. So that means if we want to find out how many days the profit is in between £700 and £1,100, we take these away. We're going to do 180, take away 70, and that's equal to 110. So that means we're estimating that 110 days the profit is in between these two amounts. So that means out of the 200 days, if you were to choose one at random, the probability that one of those days the profit is in between £700 and £1,100 would be 110 out of 200. And then we can cancel that down. We can divide both of them by 10, and that'll be 11/20. And that's it. So that's our estimate for the probability that a day chosen at random has a profit between £700 and £1,100. And that's it. Okay, let's look at our next question, question number 23. Okay, question number 23, we've got this cumulative frequency graph, and it shows information about 1,500 apples picked on a farm one day. So 1,500 apples were picked on a farm one day, and we've got information about their mass. And then if we go on down, we're told that a farmer says that small apples weigh less than 75 grams, medium apples weigh from 75 grams to 200 grams, and that large apples weigh more than 200 grams. And we've been asked to find the ratio of the number of small apples to medium apples to large apples, and we need to give that ratio in its simplest form. Okay, so let's find out how many apples weigh less than 75 grams. Let's find out how many apples weigh between 75 and 200 grams, and let's find out how many apples weigh more than 200 grams. So in other words, let's find out how many small apples, medium apples, and large apples there were. So let's start off with the small apples. They weigh less than 75 grams. So if we get our ruler and pencil and we go 75 grams, which is there, up and across, we get that's equal to 250. So that means there'd be 250 small apples, because there's 250 apples that weigh less than 75 grams, and apples that weigh less than 75 grams are categorized as small apples. So there's 250 small apples. Okay, now medium apples weigh between 75 grams and 200 grams. So let's go to 200 grams on the cumulative frequency diagram. So 200 grams is here, and let's go up and across. And when we go up and across, let's see what we get. So it's the second box below 1,500. In terms of this, each little box is from 0 to 250 in 5 boxes. So 250 divided by 5 is 50. So that means that this would be, well, we've got 1,250, 1,300, 1,350, 1,400. So that means in terms of the number of medium apples, that means that there's 1,400 apples that weigh less than 250, but 250 of them are small apples in terms of weighing less than 75 grams. So if we take them away, 1,400, take away 250, that's equal to 1,150 apples that are in between 75 grams and 200 grams. So in other words, 1,150 medium apples. So let's write that down. Okay, and then it says the large apples weigh more than 200 grams. So if we go up here, well, we know that 1,400 apples weigh less than 200 grams. So more than 200 grams would be the rest, which is 100, because there's 100 more apples to get to the total, which is 1,500. So that means there's 100 large apples. So let's write that down. There's 100 large apples. So that's great. We now know there's 250 small apples, 1,150 medium apples, and 100 large apples. Now let's write it as a ratio. So the ratio of small to medium to large would be 250 to 1,150 to 100. And that's great. Now we just need to cancel it down. So these numbers would be divisible by 50. So 250 divided by 50 is 5. 1,150 divided by 50 is equal to 23. And 100 divided by 50 is 2. So that's great. That means the ratio of small apples, the medium apples to large apples, is 5 to 23 to 2. And that's it. Okay, and let's have a look at our last question, question number 24. So question number 24 says the cumulative frequency graph shows information about the heights of 80 boys and 80 girls in year 7. And so we've got some information about their heights, and we've got these cumulative frequency curves. The blue one is for the boys and the black one is for the girls. And then if we go on down, we're told the head teacher picks one boy and one girl at random. And we've been asked to find an estimate of the probability that both students are taller than 150 centimeters. Okay, so we want to find the probability that both of these students are taller than 150 centimeters. Okay, so he's going to pick a boy at random and a girl at random. So let's go up here. We have got our cumulative frequency curves. I want to find the probability that both of them have got a height of over 150 centimeters. Okay, so let's start off by finding the probability that the boy is taller than 150 centimeters, and also the probability that the girl is taller than 150 centimeters, and then we'll deal with the fact that it's a probability for the boy and a girl being chosen at random. So let's find each of those individual probabilities to begin with. So let's start off with the boy. So in terms of the boy, well, we know that there's 80 boys altogether in year 7. So it's 80 boys, the cumulative frequency goes up to 80, and we want to find how many of them have got a height taller than 150 centimeters. So let's get our ruler and pencil and go from 150 up to the boys' cumulative frequency curve, which is there, and across. And that's great, that's equal to 70. So that means that 70 boys are shorter than 150 centimeters. And that means the rest of them will be taller than 150 centimeters, the remaining 10. So there's going to be 10 really tall boys that are taller than 150 centimeters, and there's going to be 70 that are less than 170 centimeters. So in terms of the number of boys that are taller than 150 centimeters, that'll be 10. So in terms of one of them being picked at random, there's 80 boys altogether, and 10 of them are taller than 150 centimeters. So that's going to be 10 80ths. Or if you cancel that down, that's going to be 1/8. So the probability that one of the boys picked at random has got a height taller than 150 centimeters would be 1/8, because it's 10 out of the 80, and that cancels down to 1/8. So let's write that down. The probability that the boy is taller than 150 centimeters would be 1/8. Okay, now let's have a look at the girl. So we want to find the probability that a girl is taller than 150 centimeters. So now let's go back to the cumulative frequency curve. And actually what I'm going to do is we normally would just keep our method on here, but I'm actually just going to move it just so that it looks a bit clearer for us, okay? So I'm going to bring that line to there because 150 centimeters, we're going up and across. And if we go up and across for the girl's cumulative frequency curve, we get that's equal to 60. That means that 60 girls are shorter than 150 centimeters because year 7 girls are usually a little bit taller than year 7 boys on average. I think that's right. I went to the World Health Organization and looked at the height charts, and in terms of 10, 11-year-olds, the girls are slightly taller than boys. And I've sort of made this question up based on that. Okay, so here we've got, in terms of the girls, if we go from 150 up and across, we get that 60 of them have got a height that is less than 150 centimeters. So that means the rest of them, for the girls, would have a height taller than 150 centimeters. For them, that would be equal to 20. So that means that probably that a girl who's got a height taller than 150 centimeters would be 20, because there's 20 of them taller than 150 centimeters out of the total. And we were told there was 80 girls as well. So that's 20 80ths. And if you cancel that down, you get that's equal to a quarter. So that's great. We've now got the probability that a boy is taller than 150 centimeters is 1/8. And we've got the probability that a girl is taller than 150 centimeters is 1/4. Okay, so if we go back to the question, we're told that a head teacher picks one boy and one girl at random, and we've been asked to find the probability that both of the students are taller than 150 centimeters. So if we want to find the probability that the boy is taller than 150 centimeters and the probability that the girl is taller than 150 centimeters, you'd multiply those two probabilities together. You would just do 1/8 multiplied by 1/4, and that's equal to 1 times 1 is equal to 1, and 8 times 4 is equal to 32. So that'd be equal to 1/32, and that's it, 1/32. And that's it. Now actually, just to go through this step in a little bit more detail here, if you wanted a bit more of an explanation in terms of why this is the case, think of your tree diagrams. He picks one boy at random first of all. So in terms of the boy, there's two options here. He could be taller than 150 centimeters, so he could be taller than 150 centimeters, or not taller than 150 centimeters. So they're the two options for the boy. So the head teacher picks a boy random first of all. And the probability that he picks a boy that's taller than 150 centimeters would be 1/8. And that means the probability that the boy is not taller than 150 centimeters would be the remaining 7/8. So this is a tree diagram here that I'm drawing here. And we've got the first outcome. So the probability that the boy is taller than 150 centimeters is 1/8. And not taller than 150 centimeters would be 7/8. And then the head teacher picks a girl. So in terms of the girl, they could be taller than 150 centimeters or not taller than 150 centimeters, and likewise they could be taller than 150 centimeters and or not taller than 150 centimeters. So here we've got the boy and here we've got the girl, and in terms of their tree diagrams, I'm just going to give ourselves a little bit more room here. Okay, so here's our tree diagram. So this shows all the possible outcomes. The head teacher could pick a boy that's taller than 150 centimeters and a girl that's taller than 150 centimeters, or he could pick a boy that's taller than 150 centimeters but a girl that's not taller than 150 centimeters, or he could pick a boy that's not taller than 150 centimeters but a girl that's taller than 150 centimeters, or he could pick a boy that's not taller than 150 centimeters and also a girl that's not taller than 150 centimeters. And let's label the probabilities here. So the probability that the girl is taller than 150 centimeters is a quarter, so that means that'll be a quarter. That'll be 3/4, not taller than 150 centimeters, 1/4 and 3/4. So in order to do this question, you really need to do this topic, which is called tree diagrams, okay? And tree diagrams goes through these trees. And if we want to find the probability that both students are taller than 150 centimeters, that'll be this outcome here. This one wouldn't work, this one wouldn't work, or this one wouldn't work. So we want to find this option here. And if we want to find the probability that the boy's taller than 150 centimeters and the girl's taller than 150 centimeters, you multiply the probabilities along the branches. So you just do 1/8 times 1/4, and that's equal to 1/32. And that's it. So that's how we got that answer, by just multiplying those two probabilities together. And you could consider the tree diagram, or you could just say, well, if I've got that probability and I've got that probability, if I want to find the probability of both of them happening, we can just times the two probabilities together. And that's it. And that's it. So these have been the video solutions to the Corbettmaths practice questions on cumulative frequency diagrams and also box plots. If you need any extra help on those topics, if you go to Corbettmaths and go to the videos and worksheets section and scroll down the video numbers 149, 150, 153 and 154, there's dedicated video tutorials there on cumulative frequency diagrams and box plots. and that's it. Alternatively, you can scan this QR code. But in this video, we'll focus on the video solutions to the practice questions. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. Also, if you know anyone that might find the Corbettmaths resources useful, whether it's the practice questions or the textbook exercises, the video tutorials, the revision cards, the 5-a-day books, the 5-a-days, the Forever Maths resources, or anything like that, please recommend the website to them as well. I really appreciate that. All the best for your studies. Thank you. Cheers. Bye.